Good morning and good afternoon. Thank you for joining Dyntech for today's webinar on Zero Trust Security, the role of Secure Firewall and Umbrella. My name is Brett Harmon, and I will help moderate today's presentation. During the presentation, all lines will remain muted. However, you can ask questions at any time by using the Q&A feature in your control panel, and we will address questions at the end of the presentation. In addition, today's presentation is being recorded, and we will send you a replay of the event as a reference or to share with your colleagues. Today, I'm pleased to welcome Will Wilson, Principal Architect of Network Security, as our featured presenter. Will, you have the floor.
Thank you, Brett. As Brett mentioned, my name is Will Wilson. I'm a network security architect at Dyntech, and today I want to discuss zero trust principles and how they're implemented with Cisco Secure Firewall and Umbrella. Some topics I'm going to discuss today are providing a high-level overview of zero trust. We're going to go a little bit into Duo's role in zero trust, and then I'm going to delve into the new features in Cisco Secure Firewall 7.x as they relate to zero trust and implement with Cisco Umbrella. Following that, I'll do a very brief demonstration. To start with a few overarching principles of zero trust. The concept of zero trust is we never trust, we always verify. We want to assume that there's a breach somewhere. Somewhere in your path, assume that you have an advanced persistent threat or some sort of adversary that's in your network. You don't necessarily know where, but you want to take the approach that somewhere in your network you can't trust something. So we want to apply a least privilege concept where every user, on not just their servers, but also in their network flows, can get to the absolute minimum that they need to get to. We also want to implement continuous monitoring and evaluation so that if something happens where something looks anomalous, you have something fishy, we're going to say, okay, I see something fishy, and now how do we react? And in many cases, when you have a mature zero trust framework and implementation, a lot of this continuous monitoring will react automatically and protect you when it sees anomalous behavior. The last concept that I want to briefly discuss is microsegmentation. In the zero trust framework, we often use microsegmentation to say computer one is sitting right next to computer two, but they can't talk to each other. This is a feature that we often implement at the switch layer. It's very important to zero trust, but as we'll discuss later in this presentation, we're focusing primarily on the firewall layer today. So in the traditional model, you might have users inside the firewall, and when they're in the firewall, they can get to almost everything. Many infrastructures will have access control lists between VLANs that give them some protection, but it's still at a very macro level, and it's not integrating identity. When a user VPNs into the network to get something, to access things from the outside, they're often given complete access. They VPN in, and they may have some access control lists helping protect the network, but not very much. And this allows an adversary to pivot once they get into your network and jump from host to host as they're collecting information about your network. So with zero trust, we want to thwart that. And we're going to start building the framework with Cisco Talos on top. In the Cisco framework, we have the advantage of Cisco Talos, which is the threat research organization at Cisco. They have some of the most robust feeds of data that allow them to quickly identify new threats and push information down to us as the customers. So when we use their products, we can plug in and say, new malware is found, a new malicious domain is found, and we're going to react quickly to these new signatures for domains or malware, and we're going to thwart it down at the access layer, at the firewall, and in the cloud. Now to start pivoting to the specific products. Before I go into specific products, I want to discuss MFA briefly. Most of us work in organizations where multi-factor authentication is required. However, many of us don't like it. I've worked with many organizations that are experiencing MFA fatigue, and they'll start cutting down on their MFA usage to the bare minimum. This can cause problems with users working around the MFA solution and finding ways to get in without burdening themselves with MFA. With a good MFA solution, we can implement this to improve the user experience. And as we do this, we want to remember that stolen credentials are still one of the top exploited vulnerabilities. So as we go into some of these solutions, think about what MFA means. we usually talk about the three tenets here of something you know, something you have, and something you are. The something you know is usually a password. This is the weakest form of authentication. Many of us have passwords that have been cracked, that we've reused multiple times, that you can go out to a database of cracked passwords and say, oh yeah, that's a password that I've used in the past. Something you have, this is often your smartphone, or a one-time password token, and something you are, which may be facial recognition or your fingerprint. When we start combining these, sometimes we can get rid of things like the password that many users don't like, and instead of saying you have to have a password and a fingerprint and a token, we can meet security requirements with, say, just a simple token with a fingerprint authentication. One example I like is the Ubisoft USB key with a fingerprint reader in it. I have this plugged into my laptop, and when I want to use MFA, I just put my finger on it. That's it. And if the system's configured to have no password, unless there's additional risk, then it just lets me right in because I've already met the two factors in a way that limits the impact to my productivity. And when we think about Duo and many other identity solutions, the first thing we think of is multi-factor authentication. But products like Duo are not just MFA. They include a lot more. One thing we're going to discuss a bit more in detail in this presentation is the device health checks. But they also have risk-based authentication and are able to react to threats. When we discuss the device health checks, which is now rebranded as Duo Desktop, this is a feature that allows you to run an agent on your desktop. And when you run this agent on the desktop, it can say, are you compliant? We can use this compliancy check to determine if the user is going to be allowed to authenticate with Duo. When we apply this to Zero Trust, it's going to say, I'm going to be looking at more than just identity. Instead of just authenticating somebody and getting multi-factor authentication, we're also going to say, is their firewalls enabled? Do they have a system password? In one screenshot, I showed that it could check to see if CrowdStrike is enabled. If you are a complete Cisco shop, you might use Cisco Secure Endpoint, in which case we'll augment Duo's security check with Secure Endpoint, and that'll determine the security level and compliance level of your endpoint before it's allowed to authenticate to a resource. In the screenshot I have at the bottom of this slide, it's showing an example of an out-of-date computer that had both Windows out-of-date and Chrome out-of-date, and it failed authorization and said that user is not allowed in because of the Duo Desktop compliancy check. However, I also want to emphasize this is not a requirement for the Zero Trust access on Cisco Secure Firewall. While I highly recommend using it, all you really need to do for Cisco Secure Firewall Zero Trust access is implement a SAML 2.0 solution. So you can use Okta, Duo, Ping ID, or anything else that supports, or even Azure AD, or anything that supports SAML. Optimally, we want to use some sort of compliancy checks, and there's many compliance checks frameworks that you can use that'll plug into SAML authentication. So you're not locked down to Duo, but it integrates nicely. In Duo authentication, it's not all or nothing. One of the features that Duo supports is risk-based authentication. There's a lot of factors that Duo might look at and say, this looks like a fishy authentication request. I've got unrealistic travel where suddenly I'm popping in from Germany, Saudi Arabia, Las Vegas, and it says, this is kind of fishy. Or lots of pushes are being pushed out without any responses. In this case, we can configure Duo to say, I'm not going to just block this user, but I'm going to say they need additional authentication. In the example on this slide, it's showing that it got triggered by the risk-based authentication as fishy, and so now it's going to say, you need to enter this code in your Duo mobile app. So instead of just having a push, now it's actually saying you need a 6-digit PIN. And I just want to emphasize, this is not the norm. This isn't your everyday use of it. This 6-digit PIN is only when it detects risky behavior. So it's an additional feature that says, if something's risky, turn this on. Now let's start getting towards the meat of the discussion of Cisco Secure Firewall. I'm going to talk about a few different topics related to SGTs, DNS security, secure internet gateway, and zero trust access. As we build up to this concept, I want to discuss identity and segmentation. I mentioned in one of the earlier slides that zero trust network access is often associated with microsegmentation. With microsegmentation, we'll segment the network based on identity and compliance, such that you can have almost no lateral movement within the network if you've got a really tight policy. We can implement various Cisco tools to say, if we detect an anomaly, we can quarantine a host completely off the network or put it in a part of the network that can do nothing except get updates or get scanned. When we're talking about firewalls, we're at the security boundaries. The firewalls can still use identity and compliance information, but they're typically not in the path of host-to-host traffic. You usually don't want a firewall in between every single host due to scalability reasons. So when we start looking at macro segmentation and identity, a feature that's in almost every firewall product you can buy, and have been able to buy for the last decade or two, is directory integration. This is nice because it takes away the concept of source IP, destination IP, and says, okay, now I'm going to look at things and say, this is coming from Will, or this is coming from somebody in the network engineering group. And it's going to use the identity instead of the source IP to authenticate. This is very useful because now we can have rules based on groups and users. But by default, this concept of directory integration isn't going to assess the risk level and additional features that we can look at with things like the scalable group tags. The concept of scalable group tags was created by Cisco as a way to proliferate identity information across the network. But now it's completely open standard. That means if you are running Aruba ClearPass instead of Cisco ICE, and you've got a mix of Juniper switches, Aruba switches, Cisco, anything that actually supports SGTs, you can pass this throughout your network. We can also pass these to Cisco Secure Firewall, to Cisco Umbrella, and many other third-party security appliances. The concept of a scalable group tag is when you authenticate to the network, it's going to take your identity, which not only includes who you are, but it might also include where you're coming from, time of day, compliance status of your workstation, and any factors you want to put into this policy. You'll have a centrally managed policy that's going to allow you to dynamically segment your network. It's going to map this to a group name that's got an integer value that it's going to pass to all these devices. That makes it very scalable. There's also a lot of automation. With this security group tag, if something happens and suddenly your host is not trusted, you can be re-authenticated to the network and reassign a new security or scalable group tag that's going to be pushed to all the security appliances. And we can tie this into the monitoring dashboards of various products or an overarching XDR product. So I mentioned Umbrella a couple times, but now let's define what it really is. Umbrella was originally used for DNS security. Shortly afterwards, Cisco implemented the cloud firewall option. So now, in addition to the DNS security features, we have a cloud option that is cloud firewall option that is a full robust firewall. This is nice because we can apply consistent policy for endpoints regardless of their location. If you're inside a network, you might not be running your Umbrella roaming client, but with integration with Cisco Secure Firewall, we can use the Cisco Secure Firewall's policies to enforce Umbrella policy. If you're outside of the network, we're going to have your roaming client that's going to enforce the same policy. And when I say regardless of location, I do want a disclaimer that you can set policies that's going to actually be aware of the location, and if you choose to, you can make location part of the policy. However, you could also make a very across-the-board policy. So let's get to what is a DNS security. DNS security looks at URLs, and it filters based on categories. And you're also able to expand this to custom lists. It'll block on known malware domains and on categories that you configure. The nice thing about this is it's updated by Cisco. So as Talos receives new intelligence and pushes it out to you, categories can change. A domain that was considered benign before might suddenly become risky. So you have this dynamic nature where you can say, okay, I'm going to use DNS security to look up the category or the risk level, and I can have a granular policy that's going to say, okay, if it's this risky and this category, don't allow it. And so the big punchline here, even though I only have one bullet at the bottom, integration with Cisco Secure Firewall makes it so much easier to use. The next concept is the Secure Internet Gateway. The Secure Internet Gateway contains both a layer 4 firewall, web filtering, and I added a couple things in here that aren't necessarily limited to the SIG, but part of Umbrella products of DLP, where we can look in packets for things that are being sent out of the network, where we say data loss prevention. We want to keep things from getting out of the network that shouldn't be, which ties in nicely to TLS inspection. TLS inspection is required when you want to look at the content of a packet. Quite often, we'll pass packets through a firewall, but we can't really deeply inspect them unless we open up the encryption, look inside, and then re-encrypt it and send it forward. This is a computationally expensive operation that is really nice if we move it to the cloud. A final feature I want to mention is remote browser isolation. For those who aren't familiar with this, this allows you to take risky behavior, and it's going to create a browser instance in the cloud. For all intents and purposes, when the user looks at it, they might think that they're still on a browser on their computer, other than they might see an icon at the bottom that's saying that you're actually using remote browser isolation. But they're completely isolated from their actual computer, and they're using basically, a remote desktop style browser that's just passing pixels back to them and mitigating risk. So I already mentioned one use case for Cisco Secure Firewall SIG integration. Many times you've got a firewall that you want to be able to inspect everything for malware with intrusion prevention, and you want to do deep packet inspection for things like DLP. But you don't want to open up every single packet on your firewall. The nice thing is you don't have to. Now with Cisco Secure Firewall, I believe it was as of 7.3, we can dynamically send traffic through a tunnel to SIG, and we're going to use the features in SIG to do the break and inspect and do a deep inspection. When you do this, we're going to create an IPsec tunnel on Umbrella, and it usually relies on policy-based routing to select the traffic. You don't need to use policy-based routing, but as I'm going to demonstrate in a moment on the demo, the policy-based routing gives you a lot of flexibility and granularity on what we can choose to send to SIG and what we're going to keep local. The last feature I want to discuss today is Zero Trust Access. This was just recently added to the Cisco Secure Firewall. This feature allows us to go to a URL inside the network with HTTPS without doing a full VPN. So we're going to connect to a URL just like we were connecting to any other URL on the internet. The user is completely unaware. This is going to limit what we can get to and prevent lateral movement that we have with VPN. We also have granular logging. The general flow of this is that you're going to have a user sitting somewhere on the internet. They're going to use some SAML authentication source, such as Azure, Okta, Duo, or PingID, and they're going to go to a URL that DNS is going to resolve and point them to some next generation firewall. Then when they get to the firewall, it's going to look at what host did they try to get to, what was FQDN, and it's going to create a reverse proxy to let you into the network. So with that, I'm going to move on to the demo and start showing how some of this works together. The first feature I want to demonstrate is the DNS policy. I'm going to go through these very quickly for purposes of brevity, but if anyone has any questions, we can answer them afterwards, or we can take these discussions offline. So Cisco's had DNS policies in their secure firewall for a while. The new feature now is that this firewall policy has, or the firewall policy has the ability to integrate dynamically with an Umbrella DNS policy. So we can have a policy that is static on the firewall, and then we can additionally have a policy that we're pulling from Umbrella. To get this working, I just needed to set up an API key, and then it suddenly pulled everything I had from in Umbrella. So in this case, it's going to say, what policy am I pulling from Umbrella? And if I were to match this with the policies I actually have when I go to the Umbrella dashboard, you're going to see the same policies. And so now I can adjust the policy on Umbrella to create this policy that's going to be applied everywhere, regardless if you're on the firewall or you're roaming. Then to actually enact this, we're going to go into your access control policy. If you're using a newer view of the firewall and you're not using the legacy view, then we can enable the threat intelligence directly from the access control policy. So in this case, we have the view where we say, okay, I've got security intelligence right here, and I'm going to select which DNS policy do I want to use, which Umbrella policy do I want to use, and that's going to make it in the flow of your ACP. The next thing I want to briefly show is the tunnels. So if we want to get something to SIG and we want it needs to have a tunnel, the DNS policy is just going to forward DNS requests. That's good for blocking things at the DNS level where it doesn't need to do a deep packet inspection where it's just going to say, based on the URL category, we're going to allow it or not allow it. If we want to do a deep packet inspection and look in detail, we're going to have go through a site-to-site tunnel. In a recent version of Firepower, it has an option to add a SASE topology. When we add a SASE topology, we can simply put in the information for Umbrella. We already have the API key configured, so we're going to create a pre-shared key, tell it what data center to use, and then we can just deploy this directly to Umbrella. I didn't actually even need to configure Umbrella to have this. When I clicked deploy on Umbrella, it pushed this to Umbrella and everything just came up for me. Following that, we have to configure routing. I mentioned policy-based routing. Policy-based routing, I believe, has been around since 6.6 maybe on the firewall, and it's a really useful feature. So in policy-based routing, you reference an access control list. This access control list isn't, our grandfather's access control list where we're going to have static IP addresses. In this example, in my access control list, I'm matching applications. So I could use networks, I could use users, which I haven't set up that in my demo. I can use SGDs, but in this particular case, I want to use applications. So I grabbed a whole bunch of applications that are listed as either social media or risky. And I put all these in the policy saying if they're social media or if they're considered to be a risky application, send them through the tunnel. So with that in mind, now I've created my tunnel and I've created policy-based routing that's going to push things into the tunnel. And now I can go and look at how does it behave. So I created a couple simple things here. In the first example here, we have internetbadguys.com. When you go to internetbadguys.com, this is a website we use to do a quick test of Umbrella. It's going to come up and say, okay, this was blocked due to a phishing threat. They manually keep this as a malicious domain to test Umbrella. This is not something I'm pushing through policy-based routing, so this is going to come up in as a DNS block. The next thing here is Instagram. I chose to block Instagram at the Secure Internet Gateway firewall instead of in DNS for demonstration purposes. So now if I go to Instagram.com, it's coming up as blocked. The other thing I blocked is I looked up the IP address for rsolutions.com, and I created a network firewall rule that blocked this at the layer 4 firewall rule on Umbrella. So this was something that I have in my PBR that's being sent over to the secure internet gateway and is getting blocked. If we want to actually take a look at this in our reporting now, we can see that I've got my reports and I'm going to look at my activity. There's going to be a lot of activity that we can see in these reports, but I want to focus on blocked activity. And just to show the blocked activity, I've got my identity currently is just a firewall. I didn't add any additional identity. I can say this request was firewall, and it tried to get to 34.74.254.11, which was blocked. This one is web. It went through my secure internet gateway on the web policy, and it was blocked through the secure internet gateway web policy. However, my DNS policy that did not go through the tunnel, this was just DNS forwarding to internet bad guys, was blocked using the DNS policy. With that, I want to do now a very short demo to talk about what should be a very anticlimactic end to my presentation, where we're going to use the zero trust access on the firewall to get to an internal resource. In this case, I already have Duo Desktop running, and I have a session running where I've already been authenticated. So even though you see some issues here on my Duo Desktop health checks, I've configured Duo to not block based on these. And I got in and says, yay, we're in. I didn't make much of a web page here. If this is the first time you're getting to it and you haven't authenticated with Duo, then it's going to come up and give you your Duo push. But because I already authenticated with Duo and I have it configured to remember me to minimize the impact to the user, it's relying on my Duo Desktop agent to check the compliance that I care about and then just dynamically let me in. To show some of how this works now, we have a zero trust application under policies. In the zero trust application, I simply have my external URL, which is my ztsusi.irvinglab.com. The DNS for this is pointing me to my firewall. And then it does a reverse proxy to create a NAT to an IP that can access resources in my DMZ. So it's coming in from the outside. I'm choosing not to use the intrusion prevention or malware policy for demonstration purposes. And then I'm using my SAML configuration to go to Duo Security. And once all of this works and it's happy to trust me, then I'm going to my application, my inside application, which is my SUSE internal irvinglab.com, which resolves to an internal IP address on the network. With that, I've finished what I wanted to demonstrate, and let me change my share. And I'd like to turn it over for questions and see if Brett has anything.
Great, thank you, Will. As a reminder, please use the Q&A or chat feature to ask any questions. We will be sending you a recording of today's event, and you are welcome to ask any questions via email as well. So let me see if we have any that rolled in. All right, well, it looks like we don't have any questions at the moment. So I'd like to take the opportunity to say thank you all for attending, and thank you, Will, for your presentation today.
All right, thank you, and have a good day, everybody.
Thanks.